Hey there everybody, this is Jacob Tucker, and in this video I'm going to show you how to generate images using OpenAI's DALL-E 2 model in TypeScript. After we do that, I'm going to show you how to then register and protect that image as intellectual property on Story Protocol. And the end result is going to look something like this, where we have our image right here, and we have a real legal license attached to that image and some metadata as well, so that when people want to use this IP, they have to abide by your license. So imagine things like attaching a minting fee to use this image in your own application or your merch, or a commercial revenue share where you have to share a percentage of your revenue if you were to put this on merch and sell it, etc. So first, I'm just going to show you how to generate an image using OpenAI's DALL-E 2. So before we get started, you're going to have to go to platform.openai.com and get a API key. Once you do that, you should have a free trial, but if you've used this before, you may need to actually add some billing, because every generation costs about 2 cents using the model that we're going to be using. So make sure that you generate a API key on platform.openai.com, and then once you've done that, you can go to your Cursor or VS Code or whatever code editor you're using, and we're going to go to a .env file and paste in that API key in our .env file. Now, I also want to mention that all of the code I'm going to be showing you today is going to be in the description, the completed code. So if you want to just skip the tutorial and go right to the written code, you can feel free to do that. But once you've pasted your OpenAI API key in your env file, we're going to actually dive into some coding here. Now, I want to briefly mention that what we're going to be using is let me pull it up here, is this generations endpoint. So I'll include the link to this in the description as well. But you can see that we're basically just going to be using the V1 images generations endpoint to take a piece of text and generate an image from that. And you can actually see that OpenAI gives us all this code right here. So you know what we're going to do is we're actually just going to copy this code right here, and we're going to bring it over to our code, and we're going to paste it up top. And we're just going to quickly reconfigure some things. So we're going to move this import to the top. We're going to leave that OpenAI right here. And then we're going to copy this code, and we're going to put it, actually, we're just going to delete this empty function and leave this instead. So all we did was just copy that code into our project, and we're already pretty much almost set up. Now, one thing we want to add here, and Cursor is actually already telling us we can do this, is we can add an API key to our OpenAI object here. So we want to add an API key, and we're going to say process.env.openAI API key, just like Cursor suggests. And again, that's coming from our env file that we set. Now, I already have mine set in my .env file over here. So now that we've created this OpenAI object, we can actually go into our main function here and see we're doing OpenAI.images.generate, and we're actually going to change this to DALL-E 2 because it's cheaper and quicker. And the prompt is going to be a cute baby sea otter. So we're going to leave that prompt here. We're going to console.log the data we get back from this and see what happens. So let's run npm run main. And actually, one thing I will add as well that I already have installed is make sure in your package.json you have installed these dependencies. So VM is what we're going to be using later. OpenAI is what we're using right now to generate images. .env to load our env variables. The @story protocol / core SDK. This is to protect and register our IP, which we'll see later. And the Pinata SDK, which is a utility library that we're going to be using for uploading metadata to IPFS. So make sure you have all these installed. All right, great. So now that we've done that, you should see that if you run this function, it logs a URL here. So we can actually click on this URL, and it'll take us to a page. Now, this is the image that it just generated. So this is a cool image. This is a baby sea otter, exactly as we described. So let's go back to our application, and that's very simple, right? Like in under 2 minutes or under 3 minutes, I'm seeing we have already generated an image using DALL-E 2 or OpenAI's DALL-E 2, which is so cool. Now, the more interesting part is how do we actually take this image and protect it on the blockchain, such that anytime someone wants to use that image of a baby sea otter, they have to actually mint a license from me to use, and based on terms that I set. Now, I want to quickly take a step back and talk about Story Protocol. And Story Protocol is trying to be the world's IP layer. So it's trying to make licensing much more efficient and easy for smaller creators or creators in general to license and remix their IP. So right now, if you think about it, in the legal world, if I have an image or some IPs, any creative intellectual property, and I want others to license it or remix it, I have to go through lawyers, I have to go through money, I have to spend a lot of time to draft legal licenses, and most of the time it's one-on-one agreements. But Story is making it easy for anyone to mint a license and attach it to their IP in under a minute, right? So very quickly, and so that anyone can go and relicense terms and mint a license for any creative IP. So it's much more transparent, much more efficient, and way less costly. So the license that Story uses is called the programmable IP license. And actually, this is all in our documentation at docs.story.foundation. And if you want to go and view the actual legal text, you can click here. So actually, let's go and view the real legal license behind this. So you'll see that the PIL is, again, an actual legal license that exists in complicated, terms here, where there's certain terms like expiration, attribution. So do I have to give attribution if I use your work? Can people create derivatives of my work? And then if we keep scrolling, there's some content standards and commercial use. Can people use my work commercially? Do I have to pay them a certain revenue of revenue that I earn? So all of this is configurable directly in code, and that's where Story comes in. So with that in mind, let's actually go back to our project, and we're going to start configuring some setup here. So in our scripts folder here, we're going to add a utils folder, and then we're going to add a utils.ts. Utils.ts. And inside of here, we're just going to do some basic setup. So we're going to say const private key, which is going to have a type of address, equals ox, and then process.env.private key, and this should actually be wallet private key. Now you'll see in our .env.example, there's another variable here called wallet private key. This is actually going to come from our wallet. So if you are unfamiliar with Web3, a wallet is basically your social identity or your way of running transactions or code on the blockchain. So I use a wallet called MetaMask. You should look up MetaMask Chrome extension and install it from the Chrome Web Store. And once you do that and you set up your wallet, you can actually load up your wallet, make sure that you're on the correct network, and you can do that by going to faucet.story.foundation and click on this Connect to Odyssey button. And once you do that, it'll set up your wallet on the correct network, and then you can mint an IP from here, and you'll need at least one IP token to run the transaction in this tutorial. But before you do any of that, what you can do is, again, after you connect to Odyssey, you can click on the three dots here, click on account details, and then show private key. And once you get that private key, you can copy it into your application right here where it says wallet private key. All right, so once you do that, we're going to go back to here, and we're going to import address from VM, member to install VM. And then we're going to say export const account, which will have account type, equals private key to account, and we're going to pass in the private key. So we're going to import account, and we're also going to import private key from VM/accounts, all right? So now we have our account set up in code, and we're going to do a couple more things to set up here. We're going to say const RPC provider URL equals, in this case, we're just going to actually just say https rpc.odyssey.storyrpc.io. This is going to be the endpoint we're going to use to interact with Story Protocol. And then lastly, we're going to say const config, which is going to have a type of story config, equals, and then we're going to pass in the account here. We're going to say the transport is HTTP, and we're going to pass in the RPC provider URL. Then we're going to say the chain ID is Odyssey, and just like that. And we're going to make sure to import story config and HTTP here. All right, that's going to import it at the top. I'm actually going to minimize this code here so you can see better. And then down here, we're going to say export const client equals story client dot new client, and we're going to pass in the config here. All right, and we're going to import story client as well. So now that we have this client, we can actually start interacting with our code here, or with Story Protocol. Now, one other thing we have to set up here before we get to this next part is a function to create what's called a NFT collection. So on Story, when you mint a piece of IP, you have to have an NFT behind it. Now, an NFT is basically going to be used to represent the ownership of that IP. So when we go back to our browser here, and we look at the Explorer, this is a piece of IP. This image is IP right here. But the NFT behind it, whoever holds that NFT is who owns this IP. Now that's really cool because in a way, we're decentralizing the ability to buy and sell NFTs or the rights over a IP. So I can go on the secondary marketplace and sell my NFT, and now any revenue that's being accrued through that IP is going to go to the new owner. So it's much more flexible in terms of ownership. But what we need to do first is actually create an NFT collection so that we can mint NFTs from to represent the ownership of our IP. So let's create a new file here called create collection.ts. And inside of here, we're going to just say async function main. And we're going to say const new collection equals await client.nft. And we're actually going to import client from the utils folder we just created, .nft client.create NFT collection. And in here, we're going to set a few, just parameters. The name we can say is let's just say DALL. Let's say DALL NFTs. I like that. And cursor is already suggesting a lot of stuff. So let's just tab here. The symbol we'll just say is DALL. The is public minting we'll set to true. Mint open we'll set to true. The mint fee recipient we'll just set this to 0 addresses. We don't want to really deal with like minting fees at the moment, and it's not crucially important for this tutorial. And we're going to import that from VM. And then we'll say the contract URI we'll just say is like an empty string. And then lastly, we're going to say transaction options. And in transaction options, we're going to say it's auto-completing the wrong stuff. We'll say wait for transaction is going to be true. All right. Now after that, we're going to console.log the new collection and see what happens. So let's see if we can actually get this to work. Oh, and then we'll add main here. Awesome. And then in our package.json, I'm just going to make sure that we have. Oh, I think I changed this to create collection. So now I can run this script. So I'm going to clear this and say npm run create collection, and let's hope all goes well. You'll see it is loading right now. And this is actually going to run a transaction on story. And you'll see there is a transaction hash and a SVG NFT contract. So we're actually going to take this address and we're going to save it. So we're going to go to our utils, export const NFT collection address equals that string. Perfect. All right. So now that is in our utils. So now let's go back to our main file. And before we actually go and register this as IP and set license terms on it, we need to configure some basic metadata first. So let's actually come up with some IP metadata. So we're going to say const IP metadata is IP metadata type, and we can import that from Story Protocol, equals client, and we're going to import client as well, .IP asset, .generate IP metadata. And we're going to open up this function here, and we're going to pass a few terms here. Now, if you're curious, you might be wondering, where is this metadata coming from? Well, it's coming from, if you go to our documentation and go to IPA metadata standard, this is the metadata standard that we're going to be pulling from. So you can see there's a title, description, IP type, there's some attributes here. So we're going to set a lot of these in our code. So if we go back to our code, we're going to say title. We will say, I guess just DALL-E 2 image. Our description will be an image generated by DALL-E 2. The image, then we're actually going to pass, well, actually, we're not going to pass an image here yet, but we're going to say IP type is image, and then we can add some attributes. All right. And the attributes is going to be an array of objects. And in here, it's just some key value pairs. So the key, we will say, let's say model, right? And the value is DALL-E 2, right? We can also add, let's just say, key. I'm just going to come up with some random stuff. We'll say the prompt, right? So what do we want the prompt to be? The prompt is a cube ABC otter, right? That's what we pass in right here as well. Awesome. And just for the sake of making it exactly like it is on the website, we'll lowercase it to DALL-E 2 like that. Okay, so that's the model. And it's actually spelled EL. I just noticed that as well. All right, great. So I'm going to pull this down here. I'm going to zoom out a little bit since we're getting into some more code now. So this is some IP metadata. Now what we're also going to do is set some NFT metadata. So let's go down here and say set const NFT metadata. And this is going to be very similar, but this is just going to be metadata for the NFT, which represents the ownership of the IP. So think of this as the IP itself, and this is the ownership of the IP. So the name, we will say NFT representing ownership of our image, right? The description is going to say this NFT represents ownership of the image generated by DALL-E 2. The image itself, which remember, if we scroll up in our terminal here, or when we generated that image, it was image.data.0.url. And then the attributes, which we will actually just copy and paste from here because it's very similar, we will paste the attributes there as well. Okay, perfect. So now that we have this metadata, we need a way to actually store this metadata so we can pass it in to our registration flow. So in order to do that, we need to go into our utils and make a new file called upload to IPFS. And we're going to upload our metadata objects to a decentralized storage network so that we can store it inside of storage protocol. Okay, so we're at the top of this file, we're going to use Pinata now. So const Pinata SDK equals require at Pinata / SDK. And before we dive into this, remember that there's one more env variable you have to set. And if you go to app.pinata.cloud/developer/API-keys, you can create a new key here. And once you do that, you can paste it into your .env.example right here. So you'll paste that into your .env.example, and that's the last one that you'll have to do. So once we require Pinata SDK, we can say const Pinata equals new Pinata SDK. We're going to pass in, and then we're just going to say, you know what, Pinata JWT key process.env.pinata JWT. Just like that, all right? And again, that's all coming from the .env.example. So once we have our Pinata object set up, we can say export async function, upload to, upload JSON to IPFS, having a hard time spelling, JSON metadata, any, and this is going to return a string as a promise, all right, or a resolved promise. So once we do that, we can say const IPFS hash equals await pinata dot pin JSON to IPFS and pass in the JSON metadata right here. And then we can say return IPFS hash, all right? And that's going to make this file work now. So all this is going to do is we're going to pass in some JSON metadata, which is going to come from here, right? So just this object and this object right here, right? And also, I forgot to explain, this generate IP metadata, this takes some custom metadata we fill in and then automatically fills in the rest for us. So you'll see we didn't provide any media, we didn't provide a created at, we didn't provide relationships, but it'll automatically fill this in as blank for us. And you know what? Why don't we actually set creators? So let's see, IP creator is a name, address, and contribution %. So let's do that. So let's actually add a creators here just for fun. We'll say creators. This is also going to be array, and the name we'll say is my name, Jacob Tucker. The contribution % we'll just say is 100, so I contributed the whole thing. And then the address, which will just be account, which I'm going to import from our utils file .address. All right, cool. So we added a creator. That's awesome. So now that we have our metadata objects here, let's actually upload these to IPFS. So I'm going to do that right now. Okay, so we'll say const IPFS hash equals await upload JSON to IPFS, and we're going to pass in our IP metadata, right? Then we're going to say const nft IPFS hash equals await upload JSON to IPFS, and we're going to pass in the nft metadata. All right, perfect. So now that we have done that, we're actually going to register our image as IP on story. So the next step, or the last step, is to say const response equals await client.ipAsset dot mint and register IP asset with pill terms. So long function name. And then in here, we're going to say SVG NFT contract. And this is going to be the NFT collection address that we made earlier, right? That's in the other file. The pill type is going to be pill type dot non-commercial remix. And this is where you can actually get kind of fancy. So remember, this pill type is coming from the pill that I showed you earlier, which is the programmable IP license. Now, there's a lot of different options you can use here, but the one that I'm using is non-commercial social remixing. This is a popular flavor on Story, which is basically a popular set of pre-configured terms from the pill that a lot of people use. And non-commercial social remixing says, okay, people can remix this work, they can distribute it anywhere, they must credit you appropriately, but they can't commercialize it and they can't claim credit for your work. Some other options, and you actually see what these come out to in code, right? So all of these are from the pill template. We've just translated them into code. And so you'll see the commercial revenue share is 0. The minting fee default minting fee is 0, right? So, but it does allow you to create derivatives. So derivatives allowed is true, but you must give attribution. So all that is in code. But there's other options here too. There's commercial use, which says, you know what, all of that is the same, but you actually must pay me to use, you must pay me in order to use this image, but you can commercialize it, right? So you can pay me 10 USD in order to use this image, but then you can commercialize it as well. And there's also a commercial remix and some other flavors here as well. But for this video, we're going to use non-commercial remix here because that's the most simple. People can create derivatives of it. It's free, but they can't commercialize it. So then after that, we're going to pass in some IP metadata. Now this is actually what we just set up. So we can say IP metadata URI, and we're going to say this is pointing to IPFS/IPFS, and then we're going to add the IPFS hash that we got from right here into that function or into that string. And then we can also say NFT metadata URI is HTTPS IPFS.io /IPFS /NFT IPFS hash. Now, there's two other things we have to provide here that we haven't gone over yet. One is IP metadata hash, and the other one that we haven't done yet is NFT metadata hash. Now, this is basically just hashed versions of these objects, and we can do that pretty simply. So up here, we can say const IP hash equals create hash. We're going to import that from the crypto library that should be installed. SHA-256.update JSON.stringify, and then we're going to pass in IP metadata, which is the JSON object above, and then say .digest into hex. And we're going to take this code and we're going to say the same exact thing. Actually, you can even see cursor is auto-suggesting that for us right here. And then down here, we can say, okay, this is going to be OX IPFS hash, and this will be OX NFT hash, right? So now we've correctly filled that in. Now, the last thing we want to put here is some transaction options. And in here, we're going to say wait for transaction true, just like we did for the collection earlier. And then we will say console.log the response. All right. So if all goes well, this should work. Now we can clear this and say npm run main, and let's see if we get any errors or if it works. It would be amazing if it worked the first time, all in one go. Oh, it says pinata pin JSON to IPFS is not a function. Let's see why. This, I believe this is because this should be IPFS capitalized. So we'll try this again, see if it works. But while it's doing that, just to reiterate what is going on here, we're first generating an image using OpenAI, getting a URL to it. Then we're creating some basic metadata for our NFT and for our IP, right? We're setting that here. We're uploading that to IPFS, so we're storing that somewhere, and then we're passing that into the registration here, and we're setting a real legal license on our IP so that, again, others have to properly abide by those license terms to use this image. Beforehand, we had to create this collection because this is where we're going to store all of our DALL created images, all of our IP inside of this collection. And each NFT represents the ability to represents ownership over that IP. So this function, mint and register IPS with pill terms, is going to mint an NFT from that collection, give it to the person running this transaction, and then also take that NFT, register it as IP, and then attach a legal license to it. All right, so we can see that it generated the URL, and we can actually take a look at this. So if we open the URL that it generated, this is the image that got generated by DALL. And then if we keep scrolling down, this is the transaction hash and IP ID that was generated from Story. So if we copy this IP ID and go to the Explorer, we're going to paste that into the search bar up here. And it says no results found, but probably because it hasn't loaded yet. But what we can do also simply is just go to explorer.story.foundation/IPA/that IP ID. And if we wait, there it is. So here's the image. You can see here's some NFT details that we set. So the NFT representing ownership of our image. This is, I'll zoom in so you can see it better. Right, this is the NFT representing ownership of our image. Here's the description. Here's some traits that we set, right? DALL-E 2, and this is the prompt. And then here are the IP details, right? And we can actually even view the metadata directly on IPFS. So this is coming all from IPFS here. And then we can see the creator, so I'm the one that created it, and the license that actually is attached to it. So again, you can see derivatives are allowed here. Expiration, it never expires. You can't commercialize it. And the minting fee is 0, right? And there's no, rev share or anything like that. So I hope this was helpful. Thank you so much for watching this video. And if you have any questions, please feel free to join the Story Discord or comment below. All right, I'll see you in the next one. Bye.